Good morning, one and all. Today my tech topic is unique nuclear thermal rocket engine, which is related to the aerospace propulsion. So based upon this topic, about a small introduction in which nuclear rockets. Nuclear rocket system includes the nuclear thermal propulsions (NTP), nuclear thermal propulsions systems, nuclear electric propulsions (NEP) systems, hybrid NTP-NEP concepts, and nuclear propulsion rockets that are propelled by the force of nuclear explosions, provided thrust through the heating of a liquid hydrogen propellant by nuclear fusion. Several designs of a nuclear thermal rocket, solid, liquid, and gaseous core nuclear rockets. Solid core nuclear rockets operates by the pumping the liquid hydrogen propellants through the narrow channels in a solid nuclear reactor. As liquid hydrogen moves through the channels, it is that heating by the reactor into the high temperatures and then rejected from the existing nozzle of the rocket at the high speeds. Liquid and gas core nuclear rockets operates according to the similar principles, but instead of this using the some solid fuel core to heat the hydrogen propellant, they use a liquid or a gaseous nuclear fuel respectively, which is nuclear thermal rocket. In which right side we can able to identify that liquid hydrogen, and left side we are able to identify that the nozzle, where it in connecting the tubes is known as channels. Why nuclear thermal propulsions in space can provide electricity heat propulsions for the future space missions. Due to high propulsion efficiency, faster travel method, and human solar missions reduce the fuel consumptions and increases the payload of the capacity. There are few types of the nuclear rockets: solid core nuclear thermal rocket, gas core nuclear thermal rocket, nuclear salt water thermal rocket, nuclear power electric rocket, nuclear pellets rocket, nuclear fission fragments rocket. A solid core nuclear thermal rocket. The most traditional type uses a conventional nuclear rocket running the high temperature to heat the working fluid that is moving through the reactor core. This is known as a solid core design and the simplest design to construct. The newer engines where this type, basically it's just replacing the chemical reactions which heats up the propellant with the regular fission reactors. Some working fluids is pumped through it. The fluid helps up to the nearly temperature of the core, and then it is expelled as a rocket itself. Now there is an Electronic nuclear engine for a rocket vehicle application. Nuclear engine for the rocket vehicle application in US. Nuclear thermal rocket engines developed the program that ran from the roughly 2 decades was joint efficiently of US Atomic Energy Commission and the NASA, managed by the Space Nuclear Propulsion Office until both programs and the office ended in 1972. The advantages of the solid core nuclear thermal rockets are that it is simple and straightforward, producing a lot of the thrust, and has decent high ISP. The disadvantages is that to maximize the ISP, you need to maximize the temperature of the solid materials, which became very difficult problems very rapidly. Unable to identify the diagram as shown on the screen. Second one is gas core nuclear thermal rocket. In this, the core of a NTR, which most hottest component in NTR is the gases confounded within the rocket vessels by clever means. The heat propellant is expelled and pumping can be achieved cooled as those designs, so you can achieve very high ISP while still maintaining the very high thrust of a solid core gas. Gas core nuclear thermal rockets can be identified as shown in the figures. Nuclear salt water thermal rocket. The nuclear salt-water rocket creates a continuous diffusion chain reaction in the nuclear salt-water solution within the rocket. The fusion chain reaction is kept from the space back into the fuel length by the fuel of a nuclear salt solution. The ideal due to the rocket is to maintain the flow at the rate which plus the fusion zone. Just just back of the nozzle keep the engine temperatures within tolerable limits. And nuclear powered electrical rockets. This is a one more propellant rocket. Electrical rockets also have the high ISP values, however they also have the low thrust. Typically become to throw large quantities of the reaction mass out of electrical rockets. You need to impute amount of electrical power. As of today, you have just one component along the idea is to couple a fusion reactor to an engine. Advantages: this gives you very high ISP without the putting a lot of stress on the reactor design. Disadvantages: the disadvantages is that nearly all conveyable electrical rockets are very low thrust design even with the nuclear power. This means they cannot launch a payload from the Earth. They are only suitable convenience space missions. And nuclear plus rockets. This type of a popularity known as Orion. It uses the nuclear bombs to provide the thrust via a large pulsar plate or a via leading sail. The Orion Multipurpose Crew Vehicle MPCV is a spacecraft intended to carry the crew of up to the 4 astronauts to distant or beyond the low Earth orbit. Currently under the development by the NASA for a launch on the Space Launch System, Orion is currently intended to facilitate human explorations of the astronauts and of Mars, as well as to provide a means of delivering or retrieving crew supplies from ISS if needed. Advantages and disadvantages of propulsions. Advantages: high ISP, low specific mass, high power allows high thrust, high F by W ratio, use any propellant safety, reducing the radiation for some missions. Disadvantages: political issues, social issues, low technology reliance level, radiation issues, high inert gas. Thank you.